Hello everyone, welcome to this video on gaseous law. We are going to learn about Dalton's law of partial pressure. A gas enclosed in a container of volume V is characterized by few variables which are known as state variables. These variables are pressure, volume, temperature and number of moles. By fixing these four variables, we can fix the state of a gas. In a particular state, all these four variables are related with each other by ideal gas law, that is, pressure times volume equals to number of moles times R times temperature, where R is universal gas constant. This equation is called ideal gas equation, assuming that the gas is behaving as an ideal gas. We will use this relation to understand further about partial pressures. Let us say we have a mixture of gases enclosed in a container of volume V and kept at a temperature T. We are interested in knowing the total pressure exerted by this mixture of gas on the walls of the container, and also to relate this pressure to individual state variables of each gases. So first of all, let us mark the state variable of each of these gases in this tabular form. Let us mark these gases by 1, 2 and 3 and their respective number of moles, pressure, volume and temperature to be N1, P1, V1 and temperature T, and likewise for gases 2 and gases 3. Okay. Now applying ideal gas equation to gas 1, we can write this equation P1 V1 equals to N1 times R times T. Similarly for gas 2, we can write P2 V2 equals to N2 times R times T, and P3 V3 will be equal to N3 times R times T. Okay, let us do some mathematical manipulations. We add up these equations, which will give us P1 times V1 plus P2 times V2 plus P3 times V3 equals to N1 plus N2 plus N3 times R times T. Now, since these gases are kept within same container and volume of a gas is equal to the volume of the container, so they will not have separate volume within this container. Rather, volume of each gas will be equal to volume of the container. So we can replace V1, V2, V3 with V itself. Okay. So the equation becomes P1 times V plus P2 times V plus P3 times V equals to N1 plus N2 plus N3 times R times T. Now we can take the volume common and it will become P1 plus P2 plus P3 times V equals to N1 plus N2 plus N3 times R times T. And we can now know that P1 plus P2 plus P3 can be replaced by P total, and N1 plus N2 plus N3 can be replaced by N total. So we have again arrived at the form of an equation which is ideal gas equation. It means that we can treat the entire mixture of gases as an ideal gas in which total pressure exerted by these mixture will be equal to sum of individual pressure exerted by each of the gases. Okay, and this very statement is the statement of Dalton's law of partial pressure. Let us put this statement once again by carving it out from our derivations. So, Dalton's law of partial pressure suggests us that if we have a mixture of gases enclosed in a container, then we can treat them enclosed separately in different container of same volume kept under same temperature, and therefore we can say the total pressure exerted by a mixture of gases within a container will be equal to sum of the respective individual pressure, which is called partial pressure technically. Okay, this is true for any number of gases. So, mathematically, Dalton's law of partial pressure for n gases can be represented with this equation. Thank you so much for watching. Please also watch the related video on this topic titled as gaseous laws. Thank you once again and see you in the next video.